Test mic. Okay, good morning. So I think just a bit of recap of what we discussed in the lectures. This week we've covered on the back to the CPU, but our primary focus is now more to instruction sets. Okay, so I think yesterday we've discussed on assembly language, and this week's lecture is basically an introduction to assembly language, and we have discussed on RTN and some of the addressing modes, and a few of these things are actually quite important. So I think we're just going to cover the first some parts of it. We're just going to discuss the register transfer notation and how it affects the register. So as I discussed, I think yesterday, the register transfer notation is basically a type of expression. Okay, so it's an expression to show to express your program that you're going to write. What happens to the program. All right. So we'll get straight to it. All right. Okay. Now let's assume that you have these values. You have R8 equals to 4276 hex, R9 equals to 3484. The content pointed by what's in 4276 is equals to 3AB2 hex, and the content pointed by 027C it's 91BC. Now this thing, I need you guys to actually be very clear. If you are not very familiar with this topic, please get back to me. All right. I try to explain it as much as possible. Given the initial value of the memory content, complete the question following as expressed by the RTN. So the question is actually trying to ask you, now these are the initial values. With the initial values, what happens, if you have certain register transfer notation? Okay, so if I give a transfer notation A, you have to program it according to the register transfer notation, and then what happens subsequent to the programming line that you actually type out. Okay, so we're going to discuss that now. The first register transfer notation is R9 equals to R8. This is what we call register. I'll get back to you. I think I don't want to create confusion, but let us focus on the register transfer notation first for this week. Okay, so what is the result of this register transfer notation? Now this is just an expression. When you look at R9 equals to R8, okay, what happens is you still need to code it because this is just an expression. It's a language. Okay, now okay, we've learned, if you reflect back on the lectures that we've covered, this is the source, this is the destination. So the result of this RTN is that R9 equals to 4276. Why? Now what's the reason? Because R8 contains 4276. Okay, so automatically R9 will be equals to 4276. Now this is straightforward. If you get this kind of question, you answer straightforward. Okay. Okay, now this one is a bit complicated. This is one of the reasons why I actually brought it up. If everything was as simple as question 1, then there is no need to have this exercise. But this is a bit complicated. Okay. Now R8 equals to the content pointed by R8. R9 equals to the content pointed by R8. Now let us see what is R8. R8 equals to 4276, and 4276 equals to 3AB2. Okay, now R8, what's inside R8 is 4276, but what's in this memory pointed to 4276 is 3AB2. Okay. So that's why you have the memory pointed by R8 is 3AB2. So this is is this the type of trick question why I want to bring up this exercise in the first place? Okay, so the contents are pointed by R8. Okay, register becomes the address. The R8 equals to 4276. Hence, the content in 4276 is transferred to R9. So this is slightly a bit tricky, but we're going to look into more tricky ones. All right. So the third register transfer notation. Look at this. By pointed by 0276. Okay, so this means that whatever is here is being considered 0276. Okay, you only affect the byte. Okay, so if you look at 027CH, okay, there must be a H here, but I think it's a typo mistake, equals to 910A. Okay, so this RTN affects only the lower byte as pointed by 027C. So lower byte only. Okay, so 91 is not affected, only OA is affected. The address pointed by is 91BC. So this is the content. You look at the previous slide, you know. Okay, so this one BC. All right, so the fourth reference you can see here. And since what's in 02CH is 91BC, hence you take this value, you minus off with 3AB2 hex. Okay, another trick here, if you observe this, R8 is equals to 4277. Why is this value not extracted? Because it's actually not a direct reference. It's basically a pointer-based reference. So 4276, what's in the content of 4276 is 3AB2. So this is the reason why I actually bring up these questions. Okay, so that's why this is pointed. Okay, you do the calculation, you get something. Okay, but this value is ends with it ends with 10. Okay, so this value ends with 10. This value ends with 0A. Okay, if you do this calculation, 91BC minus 3AB2, you end with something 0A. So the last two bytes is 0A. Okay, I do not know if you punch in the calculator, you will get XX0A. The XX is something you can do the calculation yourself. But we are not interested in the upper half. We are only interested in the lower half. The according to the original value, it's 91 BC. Okay, you can see that 91 is being retained. Only BC is being replaced, and is being replaced by the value you get by doing this calculation. Okay, so again, this kind of register transfer notation, it requires you to only affect what's in the lower byte. Right now, this is just this is basically just expression. Okay, if I have this and I ask you, the subsequent question, please code this register transfer notation in assembly language. Now that is another part of a difficult question that you need to answer. But nevertheless, what this register transfer notation means is that only affect the lower byte, upper byte do not touch. Since the upper byte is it's 91, you do not touch the 91. Okay, you only affect the OA. The B and C is replaced with whatever that you calculated, and the lower byte is replacing this BC. You get 91 OA. Okay, so okay, you use back whatever that you learned in the previous 3 questions, you'll be able to solve this. Now, what's pointed by R8? R8 means R8 is 4276, and what's inside 4276 is 3AB2. Okay, so you take 3AB2. 3AB2 you plus with 0, 1, 3F. Okay, you can see this is a direct approach. So 0, 1, this is a value. Okay, you use a value. So this value, all right, plus with whatever that is in this content. So 3AB2 plus 0, 1, 3F, you will get 3BF1. All right. Okay, so this you should not get confused after you've done the first 3 questions. So it's fairly easy. All right, final question. Is it a final question? We have a final question. Register transfer notation for 037C. What's in this content? We do not care. What's the value here? We do not care. But this, whatever is in this content, you have to do a calculation. So the content in 027C, it's 91BC. Okay, so 16-bit 91BC minus 4276. Okay, so the value 91BC minus 4276 equals to 570A. So this value will be transferred to 037C. Okay, this memory will contain 570AH. Okay, again, observe the brackets. Okay, it can be confusing. If you study the brackets, you should be able to do it. Again, this question, there are other similar questions in the textbook. Please go through. As a homework, I just like you to actually we haven't discussed, that's why I do not want to discuss this, but as a homework, all right, as a homework, I want you guys to have a look at all this register transfer notation, and if there's only 5 questions, okay, and if you can tell me what type of actually addressing mode they're actually using, right? We haven't gone to that lecture yet, but it's always good to study it first before we go to the lecture. So since we're still discussing in this tutorials and lecture, I just like you to look at the register transfer notation and can identify what type of addressing mode that we actually talking about. So the addressing mode means what is the method that we are transferring the information. Okay, so some are direct, some are indirect, some are actually using pointer, and so on and so forth. So that's all for this tutorial. Please go through this. This is very important for your exams. Okay, so thanks.